The isotope polonium-209 decays by emitting an alpha particle. Which of the following shows a nuclei of the isotope produced? So we have an alpha emission here of polonium-209, which has an atomic number of 84. It gives an alpha particle 42 plus another particle, let's consider it as y, and it has nuclear number of x and proton number of y. So if we equate these, so we would have 209 equals to 4 plus x. So x would be equals to 209 minus 4, x would be equals to 205. And if we do the same with these, we would have 84 equals to 2 plus y, so y would be equals to 82. So the number of protons would be 82 and the nuclear number would be 205. So 82, either this or this. So it has neutrons, so we have the nuclear number and the protons. So to find the number of neutrons, we know that the nuclear number is equals to protons plus neutrons. So the number of neutrons will be the nuclear number minus protons. So the nuclear number is 205 minus 82, which is 123. So the answer is A. Number 2. Two objects collide and rebound. Select the row of the table that is correct for the total momentum and total kinetic energy of the objects in an inelastic collision. So in an inelastic collision, the total kinetic energy is not conserved and the total momentum is conserved. But you know, the total momentum is always conserved regardless of the type of collision that we are dealing with. So the answer is B. A potential difference V is applied across two identical capacitors of capacitance V connected in parallel. So we have two capacitors connected in parallel like this. So a potential difference V is applied across each of the capacitors. Which of the following expressions give the total energy stored in the capacitors? So here the main formula is Q equals to CV, where Q is the charge, C is the capacitance, and V is the potential difference. And we have another formula which is E equals to half QV. This energy is actually given by the area under the graph of QV. So due to this, the energy formula is half QV. So using this, we can also write, using this formula, we can rearrange the energy equation as half CV squared. So we have half CV squared here, but the capacitance of these two will be 2C. If this has a capacitance C and this also has a capacitance of C, when two capacitors are in parallel, their capacitances add up. So due to their addition, the energy would be half 2C V squared. Since they're in parallel, they add up. So half into 2C V squared would be CV squared. So the answer is C. Number 4. The diagram shows an electron diffraction tube. So we have a filament here, an electron gun, and an anode. Electrons are released from the filament and accelerated towards the anode, producing a beam. A magnetic field is applied, deflecting the beam as shown. Which of the following causes electrons to be released? A. Beta decay, B. Ionization, photoelectric effect, harmonic emission, right? The answer is harmonic emission. This type of a question is quite repetitive. Harmonic emission is when the filament has such high temperatures that the electrons have enough energy to be released from the surface of the metals. So the answer is D.
The magnetic field applied to result in the deflection shown. So we have an electron which is going this way, so the conventional current will be flowing in the opposite direction. Here we have to use a Flemming flatter rule. The Flemming flatter rule with the thumb. Our thumb represents the force, our index finger represents the magnetic field line, and our middle finger represents the direction of current. So if the current is this,
so the electron is rightward, so the current would be taken leftwards as it is the conventional current which we consider. So thumb points upwards. Since the electron is going upwards, we know that the force would also act upwards. The middle finger would be leftwards, so we would find that the index finger would be pointing out of the page. So the answer is D.
number 6. Which of the following decays for ion is not possible? Because the charges in either side. So for A, this ion is in charge of 0, this is also 0, so 0, so 0, A is possible. For B, pi plus is plus 1 because it's plus 1 and electron is 0, this is also possible. I 0 is 0, electron plus 1, electron neutrino is 0. So for this, the left side equals to 0, right side is equals to 1. So C is the answer since the charges are not conserved. For D, this is 0, this is plus 1, this is minus 1, and this is 0. So 0, right side 0, this is also possible. So the only decay that is not possible for this ion is C.
Number 7. The table shows the 6 types of quarks and their relative charges. So we have up charm and top charge, top quark with a charge of 2/3, down strange and bottom quark with minus 1/3 charge. Which of the following shows a possible quark combination for a baryon with charge of minus E? So minus 1, that is. So let's see, with A, we have C, S and S bar. So we would have 2 by 3 plus 2 by 3 plus, we have minus 1 by 3 here, but we have a bar here. So it would become 1 by 3. So this would be 5 by 3. For B, we have DSS. So the addition would be minus 1. For C, we have UUD. So the addition for this would be 1. For D, it is U bar D. So the addition for this would be U is 2 by 3. So U bar would be minus 2 by 3. So the only answer that has minus 1 is this, option B. So the answer is B. Number 8. Two identical point charges Q1 and Q2 are placed a small distance apart. The force acting on Q1 has magnitude F. The charge Q1 and the distance between the charges are double. The charge Q2 is unchanged. What is the magnitude of the new force on Q1? So let's consider this as F old and the new force as F new. So the F old is Q1 into Q2 by R squared. F new is 2Q1 since the charge is doubled into Q2 by 2R whole square since the radius is also doubled. So we have 2Q1 Q2 by 4R square, which is Q1 Q2 by 2R square. So this is F new. So F for F new, we can rewrite this as, since F old is this, we can replace F old here. So this would be F old by 2. So the answer is C. Number 9. A magnet is pushed through a coil of wire at a steady speed, inducing an EMF in the coil. The following graph shows how EMF induced varies with time. The magnet is then pushed through in the same direction at a higher speed. Which of the following shows a graph of EMF against T for higher speed? So we know the formula, EMF equals to N phi by T. So if we send this at a higher speed, the time for which it is in the coil would decrease. So when the time decreases, the EMF increases. So the maximum EMF would increase. So the answer would be either B or C. But since ET is equals to N phi, ET is constant, N phi is constant, since ET is the area under the graph. So since the area under the graph has to remain constant, E increases, E decreases. So the time period would decrease. So the answer is B. Number 10. Two conducting plates are 5 cm apart. The potential difference across the plates is 10 volts as shown. So we have 10 volts here and 0 volts here. So the potential difference is 10 volts. Which diagram correctly shows the electric field between the plates? So the electric field always goes from the positive to negative. And it has to be uniform, so the distance between each lines would have to be equal. So the distance is this. So the answer would be either B or D. We have to calculate the electric field. So we have E equals to V by D. So E equals to V by D. V is 10 volts and the distance between the plates are 5 centimeters. Centi is 10 to the power minus 2. So the value of E would be 200 Newton per Coulomb. So the answer is D.